Rob Herring, for those of you that I don't know. I work in the office of the CTO. Lately I've been working on Android HAL consolidation. This is not that talk, that's on Thursday, but there's overlaps with that work in relation to Light, so Matt asked that I talk about my thoughts there. So this kind of, from the Android HAL consolidation perspective, kind of what's the problem and what are our goals? One of the big issues is how to scale board support, scaling from what you would do for 2 boards versus all the way up to 96 boards. You need different solutions. We need to change how things are done. Similarly, how we worked in the kernel to do multiple platform support, extending that also to the Android user space side, as well as embedded distributions. Other problem areas that kernel interfaces are often extended in the Android space with custom interfaces that aren't upstream and are not consistent from vendor to vendor. And that creates the problem just keeps going up as you go up layers. So what are the goals for Android consolidation? For enabling new hardware to develop the support in the kernel and be able to reuse that across different distributions. In the mobile space, that's Chrome OS, Android, other traditional Linux. For Light, it's also relevant because, as Matt's talk just mentioned, there's all sorts of different user space solutions, and we can't support them all. Getting mainline kernels to just work, and what that means is if you have mainline support, then you should have Android support and other OS, other user space. And if we're successful in this area, we eliminate HALs in Android, or there's one HAL that's kind of the de facto standard. Another challenge is every Android release is a large porting effort to bring your hardware support forward. And if you're not doing the HALs and you're mainline in the kernel, then that becomes a lot easier. And there has been kind of no upstream for HALs, and that's kind of changing with high key support in AOSP, and we hope to extend that to other devices and create a community around the HAL development. Because even when there's only one, we'll have to continue to support that and add new features and such. So kind of what does this mean for Light and how is that relevant? Kind of key points, and I think are the kernel is the HAL. This is where you clap, Arnd. Yep. So that is largely the kernel's job, among memory management and other things, that is where the hardware abstraction is. That's where we have common frameworks to share code among similar driver device types. The other similarity is that the IoT user space is fragmented, so different end users are going to want different things. We can't support them all. The kernel is the common point where we can make changes and influence that. So I've looked a little bit at Brillo several months ago. Kind of in my opinion, it uses everything that's problematic with Android. It uses the HALs, and it uses the device configuration, which is, and those are the areas that we're working on in Android consolidation. One example there that I looked at was, one of the examples is blinking an LED, of course, on the Dragon board, and the GPIO for the LED is hard-coded in the device configuration. So if you want to change the GPIO, you have to rebuild all of Brillo to do it. So I think either we look at this from the start and address these problems early on, or in 2 or 3 years we can create the IoT consolidation project. Or maybe we'll do both. So kind of common areas of interest that I see, Wi-Fi, Bluetooth, NFC, sensors, camera, low-level access, GPIOs, I2C, SPI, UART, PWM. I forgot to mention, if you didn't know before, I was working on Android consolidation. I was on Project ARA, so I can talk to some about that. And one way to think of Project ARA is it's a phone of things. And the various modules that you can add on to Project ARA phone are all interfaced through GPIO, I2C, SPI, UART, USB as well, and cameras on there as well. Feel free to ask questions anytime. So between ARA and Android consolidation, I've looked into each of these areas a bit. And Wi-Fi and Bluetooth is one that we're looking at on Android consolidation. The goals there are to get mainline drivers to work out of the box. In Android land, typically you have some vendor Wi-Fi driver that's specific to Android, including the firmware side. On the Bluetooth side, the kind of desired direction on Bluetooth is to write proper kernel drivers for that. What exists today is for UART attached Bluetooth devices, it's kind of either not addressed or hacked in how you handle interfaces other than the UART itself. So when you have Bluetooth devices soldered down on your board, you also have regulators to control GPIOs, control resets, that kind of thing. There's not really a defined way how you handle all those extra bits with Bluetooth.
Gone in, or
no, so
been patches for years.
So the plan there is to do kind of a proper UART slave device subsystem.
So that's still the plan, but it's not merged.
What's there today is kind of hacking into the line disciplines in the TTY layer, or you have some of the functionality in like HCI attach, which understands how like you do firmware downloads on each vendor and power management. So there's been several patches doing UART slave support over the last year, but it hasn't really progressed and hasn't been something that Linaro has been working on. It is on the to-do list, I think, for kernel consolidation. Switching between different modes and on Wi-Fi is common on Android devices. I'm not sure how much that would be needed for IoT type things. Maybe when you plug in your device at the beginning, you have to, it comes up with a, as an access point so you can configure it. I think that's like how Chromecast works, if I recall correctly. I'm not, for custom iOctls for Chromecast, that's maybe less interesting to IoT.
What do they do?
I don't know. And then there's probably impacts with Bluetooth Low Energy and 6LoWPAN. And NFC, in Android, that's typically a user space driver. Those are, I think, typically attached by SPI or UART. So they would benefit from the UART slave support as well.
So regarding the Wi-Fi support in general, my impression is that it's been getting much worse over the last couple of years regarding the upstream driver support for new hardware. Is this something you're planning to address? Because all the companies making those broken drivers are Linaro members.
Yes, but not necessarily those business units. So there's two aspects. I think there's new Wi-Fi standards, like a lot of what the Nexus 6 devices need to do Wi-Fi calling and handover type stuff. I've heard a lot of that's gone in and doing roaming on Wi-Fi and that kind of thing. Generally, the entry drivers can work. They're just not necessarily optimized for Android needs. I think some of the firmware differences are like how often it will wake up the host device for when it has data or things like that to be more power optimized. On sensors, kind of the standard here is IIO, is the kernel subsystem name. There's a user space library called libiio. The link is there. One thing we're seeing is sensors ranging from simple to complex. So you have simple things like ADCs and accelerometer, moving to more complex things. In mobile, it's sensor hubs. There's also people doing processing pipelines and FPGAs that need controls at various points in the pipeline. There's work ongoing. I think the initial kind of refactoring of it's going into 4.5. But to use the Video for Linux media controller for IIO, because it's a similar problem. You have a graph of nodes, and you need to control each node. I'm sure there's probably more issues around IIO. I think it's something that Linaro needs to be heavily involved in and kind of find the next level of problems around that. Camera, so Matt talked about this at the last session. I think there's probably different areas here. I think originally the idea on camera was more on like firmware for SLR cameras, which is a huge stack of software and very lots of processing on the image. Mobile's the other part, which is getting more and more complex there. And I think you can kind of divide it up. There's smart sensors and raw sensors. The smart sensors are very hard to decouple from the image sensor processors that are on the mobile SoCs. For Project Ara, it's something that issue has not really even been solved. How you would mix and match sensors with APs. So the easier path there is smart sensors, which I think for a lot of cases that's a path that you would want to take in an IoT device, as you're not going to have unless that's the central focus of the device is a camera, that you're not going to have a whole team of people working on software to do camera that you would need. So kind of the problem area there is there's little support upstream for camera. The vendor kernels copy sensor drivers and all have 10 to 20 sensor drivers in their trees. They're all kind of do the same thing, but there's not a standard API to write to for a sensor vendor. There is in mainline, but it needs to be extended to address some of the shortcomings.
I thought there was at least one vendor that used only the upstream APIs, so it has to work at least to some degree, right?
So what I've seen in vendor kernels is they either don't use video for Linux or they do use video for Linux, but then they add all their custom vendor octals.
Have a look at the Cisco kernels.
Cisco.
For their IP phones.
And in other markets like in Chrome OS devices, they've bypassed this problem by using USB cameras, which are much easier to support. Sorry? I didn't quite catch the question.
So you said the camera actually is not standardized. So you mean the 3A framework? The camera 3A framework, auto detection, face detection.
So getting into processing like that is a whole other problem that's more on the user space side. That's not really what I'm talking about here, but that is something that needs to be looked at as well.
Okay.
I'm not sure how much face detection is relevant to IoT, and I haven't really heard what the exact camera use cases are. But I think it's somewhat different than the typical camera device use case where you're taking photos.
Like previewing, preview,
So face detection, not face recognition.
camera preview.
Right. Yeah, it's definitely a complex problem, and an area that Project Ara has struggled with. So back to the low-level APIs, there's opinions that we should never have the low-level APIs, but there are use cases for them. When kernel drivers are not possible, typically these are just either direct access to sysfs or a /dev device, or a thin library that provides access to the devices. So there's a couple that I've looked at a little bit. LibMRAA and libsoc. Both of these are relatively new and have a couple limitations. Both of them require board-specific support in them, which, going back to how do you support 100 different boards, that solution doesn't scale. So we need to fix that problem where we discover capabilities and functions by describing them, not by what board we are on. So kind of in a comparison between these two libraries, so libMRAA is actually an Intel IoT project. It is it's board support, but it's runtime selected. It's BSD licensed, and it has some amount of community around it with around 50 contributors, I think, if I recall correctly. Libsoc is another one. It's basically one guy that has written it. It's build time configuration for which board you're on, and it's LGPL licensed. So as I mentioned, the board configuration doesn't scale. We need identification by function or location. So it's something we've been looking at. Device tree is probably part of that answer, but then there's updates to these libraries to utilize that support. So GPIO is one area in particular that's a challenge. The current kernel interface with sysfs is problematic because you don't know which GPIO line is which unless you know what board you're on, and so the kind of issues it has is the kernel's GPIO numbering space is exposed to user space. There's no way to retrieve a GPIO by function or know what the function is. There's no way to control multiple GPIOs together efficiently, at least. So if you wanted to do bit banging of some protocol in user space, every transaction is going to be multiple writes to sysfs. And then there's numerous issues of hot plug of GPIOs. Some of those have been getting addressed with Project Ara. User space side doesn't really address that yet. And we're looking at how to describe GPIOs in device tree, and then that would get exposed to user space. So another area is kind of add-on boards, capes, shields, lures, mezzanine boards. How to handle these for multiple baseboards is a challenge, how to identify them. We do have a solution called device tree overlays that is partially in the kernel. There's still several pieces missing there. Main couple of them are user space interface is not yet mainlined, and how to apply overlays in before you boot the kernel. And there's also a need to describe connectors on boards so that you can take an overlay for a specific mezzanine board and plug that into different motherboards and apply that to the device tree of the motherboard without in a generic way. So the problem there is on one board, the I2C device is on one I2C bus of the SoC, and then on another board, it's on a different I2C bus. And that's it. So what am I missing from here? What else, from kind of hardware standpoint, layers should we be looking at for light? Mike?
Like as you already know, like for all these things that we are implementing, some of the stuff will go through libudev or some other utility that would give us all the GPIO numbers or traversing through the device trees or getting anything from device nodes and such things. Is there a thin layer in Linux that we can come up with instead of putting bulky libudev for any of these light devices, or which is Android, Linux distribution agnostic and such things? I know you got my question, maybe you can frame it better.
Well, I would argue that libudev is standard and
Yeah, but it is
for
bulky.
everything but Android.
It is bit bulky, like if we are looking at
It's less needed if we're not talking about hot plug. So for the cases where it's static, then trying to solve the UDEV problem is less important.
And UDEV doesn't handle separate GPIO lines. It would handle the GPIO controller node at that level, I guess.
Yeah, so there's work underway for GPIO to move to a character device-based interface. Yeah, but I think hot plug is
That is
not
further out. So at the moment, there's work going on for GPIOs, but that doesn't directly tie into LEDs and PWMs, which would require a separate device.
Yeah, I think hot plug was a central issue on Project Aura, or is a central issue. It's probably less so for IoT.
Have you thought about cryptographic engines or APIs which could be common for applications, or
What's missing about those?
if you consider abstracting them?
So there's already a user space interface for the kernel for the in-kernel crypto API drivers. One time it was called crypto dev. I'm not sure what, it was out of tree for years and years. I think finally got upstreamed a couple years ago. But now a lot of the crypto is done with Neon, and in that case, you don't have a driver.
No, you have, with crypto, you have two distinct ways of doing this. You have crypto instructions, which are usually available to both kernel and user space.
Right.
Those tend to be symmetric ciphers like AES and things like hashes. You also have the asymmetric crypto, like sorry, I'm lost now. You have the ones that is asynchronous, and that is a device driver that you talk to, and that's usually not available to user space without going through the kernel driver, and that's the one you're thinking of. I also don't know what the name is of that driver, but I thought, yeah. But that's there, right? So this.
It's inside the kernel, so the question is if from user space, I don't know if any good solution now for user space.
Well, it exposes it to user space, and I think OpenSSL can use it, for example.
So OpenSSL certainly does talk to the kernel. I don't know whether there's what the generic interface is. I remember that like 10 years ago we had one or two drivers that had their own user space interfaces. I thought this got unified when we had the in-kernel crypto API. And back then, 10 years ago, the abstraction layer was basically the SSL engine library.
It's synchronous APIs.
For asynchronous.
It's all synchronous. If I remember correctly, it's all synchronous.
Oh, the user space interface was synchronous,
so
yes.
if you want to use a hardware accelerator, you're still restricted to synchronous interfaces. That's one issue.
Why is that a problem?
If you want to use asynchronous crypto, that basically.
I don't get it, because in the end, you end up synchronizing anyway.
In the hardware.
No, in the user space application. At some point, you end up having to synchronize because you have some data that you want to encrypt, and then you do something that depends on the encrypted data, and at that point, you have to serialize.
Depends how many threads you have using crypto. How many processes of threads you have using.
I still don't get your point. We should probably move on to something else. We can continue this later.
Well, we can keep talking because that's the end. I mean, perhaps we should look at kind of what are the use cases that we care about doing crypto in user space first, and then figure out where to go from there. Any more questions? All right, thanks.